A peripheral device connects to a computer to add functionalities. So basically, these are the external devices connected to our computer. So earlier, RS232 protocol was used. So what was the problem with that? So to connect a new device, we need to restart the system. There was limitations in terms of bandwidth, and there was a need to standardize peripheral connections. So to solve these problems, later PCI protocol evolved. So let us talk about that. So PCI was created in early 1990s to fix the shortcomings of old bus systems like I talked about RS232. So back in those days, ISA, so ISA was also a type of protocol which full form was in industry standard architecture. So it was great for older computers like 286 machines. However, it struggled with increasing demands of faster 32-bit computers. So it had problems like it was slow, it lacked modern features like plug and play. It used large connectors with lot of pins, which made it very tough to use it. Then companies tried to address these issues with alternatives like IBM came with MCA, channel architecture, EISA, and VESA, but none of them gained popularity. And then, so how did this PCI change everything? So, PCI was developed as an open standard by a group of companies under PCI SIG. So, this is very popular in present day also. So, PCI special interest group. So, the advantages of this PCI new protocol was that it was faster than older bus systems like ISA. It allowed software to easily manage device memory and resources. So plug and play setup became much simpler, and PCI became the standard bus for connecting peripherals in computer and was adopted by many manufacturers. Any questions here? You can interrupt me anytime if you have any question.
So I
And
just have a
then,
doubt. Like, what? Hello.
yes.
So what does mean like a plug and play?
Like can directly connect it to the computer with the help of a plug. Like earlier we have to restart the system again, and then we the system would configure that device. So would anyone would like to answer this question
Yeah,
which he
so
asked?
plug and play kind of. So take example of USB, right? You have a USB device. So when you
Mhm.
connect this, right, automatically one message pop up in your device like something is connected, and when you plug
Yeah,
it out,
right.
it will get out. So no need to restart or like you have to do any loading of software or anything, right? Already detected by the device because in your voice, right? Already the software is installed for a particular pen drive. Similar way in PCI, right? So PCI talk with physical layer. So whenever you connect or disconnect, right, the clock will not go there. Clock will present every cycle every time. So whenever you connect the clock, it will get the connect the device. The root complex will get the clock and it will detect the device as something is there. So no need to restart or reboot the things.
Okay.
Yes.
Okay. Yeah. Got it. Thank you.
Yeah.
So next comes the PCI-X. So it was introduced as a improved version of PCI. So while PCI solved many problems, new demands for higher performance led to PCI-X a few years later. So the goal of PCI-X was to improve performance while maintaining compatibility with PCI. This means that older PCI devices would still work with PCI-X systems. So PCI-X 2.0 took things even order, reaching the speeds of up to 4 gigabytes per second. So the limits of PCI-X. So despite the improvements, PCI-X had its limitations because it was a parallel bus. So in a parallel bus, data is sent across multiple wires at the same time. While this worked well initially, it eventually hit a speed. So it had speed problems. So parallel buses came with several challenges. So because it needed high pin count, slower speed compared to what new technologies demanded, significant issues when trying to push for faster speeds. So, any questions? So, let us take
So
example.
PCI is
Yes.
so PCI is a series, ma'am. PCI-X.
Yeah. PCI-X was made when PCI had some issues with it, and PCI-X
Yes. Just to add, so PCI-X, right? It was developed in 1995. So there was couple of advantage. The first one is the bandwidth, right? I mean, if you go for the PCI, right, the generated in 1990 somewhere, that was very slow. Latency was very high. So 1995, when we come up with new solution called PCI-X, X represent express, okay, express card. So with this, right, we solved this latency problem. But again, as she mentioned, right, is having a parallel bus interface. That means for every data, right, you have to send like number of data lane will be more. Additional, you have to send clock also from host to the endpoint. So if you go for the like longer time, right, when the chip is getting shorter and smaller, this is causing the issue. Like I mean, you need a bunch of serial lane which you have to connect between your both devices. Apart from this, like you know about the skew, right? Skew and what something called
Yes.
induction effect that will get introduced in the communication. Noise get increased, so we drop this. But yeah, there are significant improvement in the bandwidth.
Yes.
Okay.
So now let us take example of a PCI system. So it have a north bridge and a south bridge. So at the top we see the north bridge which connects to the processor to the system memory. So kindly please mute yourself.
ಚಾರ್ಜ್ ಇಲ್ಲ ಹಾಕದು ಯಾವುದಕ್ಕೆ
Okay. So let me repeat. So north bridge and the so we were talking about the north bridge and the south bridge. So here you can see in north bridge which connects the processor to the system memory and other high speed devices like AGP graphic like this graphics and SD-RAM. So the processor communicates with the north bridge to the FSB or the front side bus. So this is a critical part between the processor and memory. So the PCI bus runs here at 33 megahertz, acts as the main highway for the data communication between North Bridge, Ethernet, SCSI, and other components. And let us talk about the South Bridge. So managing so it manages the peripherals. So the South Bridge manages the slower peripherals like ISA, IDE, USB, and other legacy components. It also handles systems like reset, error reporting, and reference clocks. So, any questions related to this architecture?
So here like a north bridge and south bridge. So is that just a name or like inside there something is there?
No, this is just an example. So in north, we have connected the processor, whereas in south, we have connected the slower peripherals like ISA, IDE, USB.
No,
Okay.
actually, no. So basically, the notch which you have mentioned there, right? That is called as a root
Yes.
complex or root port. So which is communicated with directly with the processor. Okay, and the south
Yes.
bridge what you have point device which will communicate with your peripherals application which you want to communicate. Like you have like a BROM, I mean, RAM is there, memory is there, NVMe card is there, right? That you're going to plug there.
Okay.
And you can see the slot, right? The clock which you have mentioned about 33 megahertz. That is synchronous clock. You can see, right, the same clock you're passing to the south bridge as well as north bridge. Okay, so the computer, like what monitor or whatever you have, right, like laptop or whatever you're using at your home, it is having only four component. One is your monitor where you see a screen is there, right? I mean desktop, what you call, and there is something called graphic, and one is a storage element, and other is a PCI. So whatever the communication you're going to do, right, whether it is USB, Ethernet, or whatever, it will go through this channel only. It will go to the PCI EP. EP will say like, okay, it is a memory read request or write request. It will go to the DDR or whatever it is in your memory in your device. It will take the data from there and process it and send it back. Whatever means you, if you want to do read or write operation, accordingly the command will taken care by the host itself.
So is this North Bridge and South Bridge like an interface then PCI and the processor?
Again, if you go in deeper, right, might be see we explain in the next slide. They have something called a layer, right? Physical layer, data link layer, TPL, then your application layer, right? So application layer
Yes.
always sit on memory element. Let's suppose I want to read something, right? How am I going to do this? I will send the TLP packet, then it will go to the DLP. Physical layer will send to the other point, other like whether it is like from the request from the EP or RC. Accordingly, it will get processed and send it back. So here the application layer will connect it with a DDR in your host. I'm talking about host RC, the not bridge. Processor will monitor this because right, in CPU we have like 8 data bus and 8 address bus. So
Yes.
processor need to allocate this data bus and address bus accordingly, right? I mean, they have multiple things will going on there, right? It's not always free.
Yes. Okay. Yeah.
Right? I
Okay.
mean,
Yeah.
if you're not
Yes. Please continue.
So
yeah,
here's
so
so that is see the working of PCI bus with the help of a timing diagram. So here is address. We are sending address and data in the same on the same bus, and and first our so bus CMD stands for the control commands, that is, please mute. My screen is getting shared, right? So okay, so in PCI we send address and data at the same time on same bus as shown here, and here we have bus CMD, which means is read or write, and byte enables like how many bytes we are sending, and then IRDY means initiator ready. That means is the initiator ready to send the data or not, or and this is target ready. That means our target is ready to receive the data or not. And this is device select, and this is frame, which help us know that the data we are sending it is valid or not. And so in PCI, we have first address phase and next three are the data phases. So any questions in this?
What is that last one? GNT. Last signal, GNT, grant or something.
I think that is a grant signal, like it requests is get granted or not. I mean, when the bus command. So AD is like embedded one, right? Embedded address and data bus same. So how you comes to know this is the address or this is the data? So this bus command interface is there, right? That will give you a significant. Okay, this is coming as address. You have to take this as address, and later follow up by the address, right? You will get the data. So this ground signals will say all the signals, whatever is action is happening, right? It is correct. If we see for all the action, right, it is always one. If this is down, that means you have to again go back and see something messy has happened, like some corruption or something has happened at your end. The data which you are sending. Yeah. So again, you have to check the logic and see what is happening there. But this is a very old protocol. Nowadays, no one is using this.
Yes.
Okay.
But still, PCI still it is software compatible. Like it is still compatible with PCI devices, right?
So the second last one, DV select, dev select.
It select
That is like a
devices.
device select.
Okay. So multiple device, or like how it will?
So
Acha.
basically, I mean, nowadays they are using something concept called DMA, direct memory access. But earlier this concept was not there, right? So let's suppose you want to access something, right? You need to wait for the data lane to get free, right? So once you start communicating with, let's suppose you have two pen drive, you are connecting like communicating with one pen drive only. At the same time, this time, right? I'm talking about PCI, not PCIe. So the other peripheral will wait for each turn. So once this will get done, then it will select that second device. You cannot do multiple transactions in one go in PCI.
It is a point-to-point connection actually, no?
Correct.
Oh no.
No. PCI
Actually,
is
it is.
PCI you are talking about, right?
Yeah, PCI is
No,
a point-to-point connection.
Then you go with serial, right? Serial to serial, then PCIe onwards.
This
yeah, we
PCI
can
is
move forward.
parallel. So we will be talking ahead also that why we need parallel over, like why we need serial over parallel protocols. We will be talking it ahead, but this Zoom is giving me warning that it will shut the meeting in next 10 minutes. What we should be doing, because this is not this premium
Can we
subscription
switch
of
to
Zoom.
Google Meet?
Yeah, but it is not showing me the record section.
In Google Meet, okay, so Google Meet has already stopped this functionality where you can record it.
Yeah,
Otherwise, you
I
can
think
use
it is
Microsoft Teams, but not
okay.
everyone would have like installed that thing on their laptop.
Okay.
Maybe for the next time.
Okay, let's see what we can do. We will change the
I
Google
think,
Meet link.
I think we can reconnect again. That will work.
Pardon?
I think if we reconnect again to the meet, we could.
I think he's
Anushka,
trying to say that you can the link
Okay.
and share it.
we
Okay.
can start now. We will see it later on.
Okay. So today
Yeah.
my agenda was like talk about PCI, like some bandwidth calculations also, and how does some differential signals also which are there in PCI. And then next week we will be going through the configuration of PCI and the architecture also, which is most important. So today it was an introductory meeting talking about the why we need PCIe and what is PCIe. So should we stop it and restart the meeting with Google Meet? Anyone
Yes,
I
yes.
mean,
answer?
yeah,
Yeah.
you can share the slide material, right? Even if we are not able to find the recording again.
Okay, I will post this session on YouTube, and whoever have missed can watch it again. Okay, I'm sending the Microsoft Teams link. Is that okay?
Okay.
Yeah, yeah, it is fine.
Yeah.
So we will start with serial and parallel protocols. So having a background of what how these serial and parallel protocol is essential, that why we actually need the PCIe protocol. So the parallel protocol is where address, data, and other control information is sent at same edge of log. That is, we are sending parallelly, as shown here in this diagram. In serial protocol, we send address, data, and other control information at consecutive clock edges with few bits sent at a time. So parallel protocol is using 32-bit interface. Serial protocol is using 1-bit data pin. Then parallel will be 32 times more efficient than serial. So parallel protocols like AXI, AHB, APB are limited by the frequency of operation. So any question on this?
If you can elaborate what is AXI, AHB, and APB, maybe afterwards, you know.
Okay, I have my notes also on AXI, AHP, APB. If anyone want to understand at how they work, you can go through it. And if you want to understand PCI, so today we are not going so much depth of PCI. If you want to learn it, you should have understanding of one communication protocol at least. So that gives you an edge. And also in college, you must have studied computer networks. If you have studied that, then understanding architecture of PCI is not so difficult. And then
So I have a question. Like before going for PCI, like which basic protocol should like a knowledge should have like a APB or AXI or like a SP2, I2C or SPI or.
yeah, you should do APB first. So that is very basic and easy to understand.
Okay, okay, yeah, sure. Thank you.
So let us start with the introduction of PCIe. So we have gone through PCI RS232. Anyone would like to tell that what were the disadvantages of those protocol? We talked just now only, because if we don't know that what were the disadvantage of those protocols, then learning that why we need PCI protocol, it is it does not suit so it does not looks good, because we don't understand that why we need to learn PCI.
So as you mentioned in an earlier like a slide, like a RS232 protocol, right? So the disadvantage is like if we want to connect another device, we need to restart that machine, and after we need to reboot, and again after we can connect another. So that is a disadvantage. Over that, we have to use a PCI.
Yes. And what were the disadvantages of PCI protocol?
Bandwidth limitations.
Yes. So it has slower speed, high pin count, and significant issues when trying to push for faster speeds because it is a parallel protocol, and we just now learned that parallel protocols are limited by frequency of operation. So we will understand what does actually this frequency of operation means in our coming slides. So let us start with PCIe now. So PCIe stands for Peripheral Component Interconnect Express. So PCIe is a significant upgrade from previous protocols, that is PCIe, offering improvement in performance efficiency. Unlike its predecessor, PCI was a parallel bus system. PCIe operates as a serial bus. So PCI was a parallel, and PCI Express is a serial protocol. So more like fiber channel. So although it is based on serial model, PCIe is fully backward compatible with PCI software, making it easier to integrate with existing systems. That is, still some of the devices are still working on PCI system. So PCIe uh, should be compatible with PCI software also. So PCIe adopts a dual simplex connection model, which means that it has separate paths for sending, that is transmitting and receiving data, allowing communication in both directions simultaneously. So this step is technically full duplex, but PCI use the term dual simplex to emphasize that each path is one way. So, how does communication take place in PCIe with the help of link and lanes? So, what do you mean by link and lanes? Anyone heard about it before?
So before that, I have a question. Like, what does that mean? Like backward compatible with PCIe?
Like,
Okay, let me explain, Anushka. Just correct me if I am wrong, okay?
okay,
Actually, PCIe is a parallel serial protocol. It is extended from PCI and PCI-X. That is, PCI and PCI-X is a parallel protocol, okay? Now, what happens? These are the existing protocol. So we convert the parallel protocol to serial protocol. So most of the devices has this parallel protocol. So backward compatibility means that the PCIe is can handle the transaction of PCI and PCI-X. Okay.
Okay.
yes,
So they use like PCI and PCIe buses, or like how can I understand like that
Okay,
handles?
let me explain. Anushka, can you go back to slide number 1 where you have that signals ABP, XI?
which one?
Yeah, yeah, this is okay for me. Yeah, that waveforms.
Which
Second slide,
waveforms?
maybe.
This.
Yeah.
Yeah.
You can see these are protocol. There are two types of signals. control signal, status signal. Okay, control signal means you will have address. Okay, control signal means ready. Ready means there is two things in a protocol. Okay, I start
Mm-hmm.
protocol is a set of rules. Okay,
Yeah.
there are a few signals, 10 to 12. Okay, if
Okay.
one signal is goes high, then we have to send second signal. Okay, from this waveform you can get that address we send. Okay, then data. These all are parallel in nature. At each clock you are giving some data. Okay, master is giving
Okay.
data. Suppose I am the master, you are the slave. Okay,
Mm-hmm.
think like this, and we are
Okay.
connecting with each other with these signals. Okay, if I want to
Uh,
send any signal, any data.
Sivam, sorry to interrupt you. So basically, don't relate this PCIe and PCI. Both are different, right? As you mentioned, like PCIe is a serial to serial communication, right? And this is parallel communication. So
Right.
you have to put some hardware in between that again converts serial data into parallel form and parallel to serial.
Yeah, that we have a release for that, right? Topology, when we come to topology, we will cover this.
Correct. So basically, the basic example is like, let's suppose you have a USB, right? USB 3.0 of 3.1 that will support somewhere around 16 gigahertz, 16 or 20 G.
Right, right.
So right, and you purchase a new hardware, new laptop that supports USB 4 or USB 3.1 something like that, but you are having 2.0, right? So it
Right.
doesn't mean like if it is supporting 3.1, it will not support 2.0. If you
Yeah,
plug your pen drive, it will support. So that is called backward compatible. Like though your laptop, though your PCI is supporting higher bandwidth, if you can connect a low speed, like a low bandwidth device, it will get detected automatically.
yeah, that's I
So
am
you
explaining.
you mean I have let's say I have a latest laptop, right? And I have a like a USB 3 port to connect the pen drive, and I have a older
Correct.
pen drive like a USB 2, so I can connect it with the USB 3. So that
True.
means
Correct.
backward
Right, right,
compatible,
right.
right?
Yes.
True,
Correct.
true.
Okay, okay, yeah, got it. Thank you.
In this technical term, PCIe is compatible with PCI and PCI-X. Okay, now you can understand.
Okay. Yeah, understood. So, in short, laptop is connect. Means nowadays laptop is coming with the latest technology PCI. But if I have anyone have a older like a PCI or PCI, sorry, PCI and PCI X version, then that is we can connect that
Right, right,
device
right.
and the latest
Right.
one. Okay. Yeah, got it.
Okay, one point we can remember. In the PCI and PCI-X, we have a IO transaction. You will not understand this at this time. Okay, but
Okay.
remember this: PCI and PCI-X has IO communication. IO read, IO write. Okay, in the
Means
later session
input
you will get
output.
to know. Yeah, input output.
Mm-hmm.
Okay, Anushka,
Okay.
you can start forward.
So let us start with
Anushka, Anushka, can you just let other people in the meeting? Because
so Gen 5 works at 32 giga transfer per second, so that in 1 second we can transfer 32 gigabits. So overall bandwidth will be we multiplied the 32 giga transfer per second with 32 lanes, and as we are calculating for both transmit and receive, that is why we multiply 2 here, and we get 2048 gigabits per second, which is equal to 256 gigabytes per second. Now if we want to calculate the overall bandwidth for Gen 6. So Gen 6 works at 64 giga transfer per second. So as we are calculating for 32 lanes, so and we want to calculate for both transmit and receive, we multiply by 2 and we get our calculations like this. So let us understand some more basics. Like let us take an example of a chip. So a chip have 2 gigahertz frequency. So that means what will be the time period? 5 nanoseconds. If we have 4 gigahertz frequency, then we have time period 2.5 nanoseconds. So what do we notice here? So as we increase frequency, meeting setup time becomes more difficult. Like discuss the major problems with the parallel bus. So the flight time. So this is the delay caused by the time it takes a signal to travel from the transmitter to the receiver. So in parallel buses, signals must arrive before the next clock cycle. But as the clock speed increases, it becomes impractical to shorten the physical length of the traces or reduce load. Any questions on this, on the flight time?
If the number of lanes increases, like 32, does it behave a parallel kind of communication because of the number of lanes?
No.
Okay.
So now let us talk about. So the next problem with parallel buses is the clock skew. So this happens when the clock signal arrives at the sender and receiver at different times. So this complicates the synchronization. And next is the skew. So in parallel buses, all the data bits should arrive together at the receiver. However, signal skew causes bits to arrive at different times, requiring the system to wait for the slowed bit, which affects the advantages of serial communication. So in its flight time, it no longer matters how the signal takes to reach the receiver because the clock arrives with the data. It is embedded with the data and clock skew. So there is no external reference clock, so the skew is irrelevant. And next, the signal skew. In signal communication, only one bit is transmitted at a time, eliminating intra-lane skew. In multi-lane setups, any inter-lane skew can be corrected automatically by the receiver.
So I have a question like what does mean like clock is embedded with data?
Would anyone like to answer this?
Okay, let me try to answer this question. So, as he said, like we are sending data serially, right? Let's suppose I'm a transmitter, you are a receiver, right? So I'm sending
Mm-hmm.
data serially, like one data 0101. I'm sending to you. So it is
Yeah.
having data information, right? So you how you comes to know like at what clock I'm sampling the data? You can't, right?
Yeah.
So their receiver side, you comes to know there is something called CDC, clock data recovery circuit.
Yeah. Clock domain crossing CDC.
No. CDC is different, right? That is a clock domain crossing. This is different. I'm calling it clock data recovery, CDR, clock
Okay.
data
Clock
recovery.
data recovery. Mm-hmm.
So basically, they are having some flip flop and mux will be there, and receiver side, as is told you, right? So you the first picture, right, where the north and south bridge was there.
Yeah.
Slot clock you can see there, right? The
Yes.
same
Yes.
clock you're giving to both, like your north bridge as south bridge, right?
Yeah.
So
33
this
megahertz.
clock can be is used to just recover the data because both you and me sample is same. We both are synchronous, right? I mean, we both working at same clock frequency, right?
Same clock
So
cycle. Yeah.
so if I put the same to the flip flop and try to recover the data, I can recover it, right? I mean, something called
Yeah.
so that clock will feed there, and from there we try to recover the data. Okay,
Okay.
so benefit of having this like we have reduced two more, data, lane, you can say, or physical lane, clock. So clock also we are sending with data that will call as a clock embedded things. Might be C will explain in couple of days, like PMA section will be there. There C might be having something called uh, uh, PISO, parallel in serial out. Okay.
Okay.
Yeah.
Yeah.
So there you will see like how it is getting embedded data and
Okay.
clock.
Okay. Yeah. Got it. Yeah. Okay. Sure. Thank you.
So we already did the bandwidth calculations. Was that useful for you all? Did you understand it properly?
Yeah, we understand, Anushka.
Yes.
Okay.
So one
So
question I have, like a Gen 5 supporting 32 giga transfer per second. So that is a speed, and it's like allow for 256 gigabyte per second, that bandwidth, right? So on that bandwidth we can transfer the data. Am I audible? Hello.
Yeah, that's just a speed.
Okay. On that speed we can transfer the data, right?
Right.
Okay. 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 Yeah. Sure.
So let us talk about differential signals and then we will end the meeting for today. And in next session, we will talk about the configuration and architecture. Okay, is that okay for everyone?
Yeah, it's okay. Can you know when the next session will be?
Do you want it every day? Is it comfortable for everyone or weekly sessions?
Every day.
No. Okay, it is comfortable every day.
But what
Okay.
time?
But
It,
weekly is better, but I'm not.
At what time? Sir, every day.
Daily
so,
1 hour, it is better to keep.
No,
okay.
it's Anushka, keep it on weekend only.
Yeah.
Actually, here we are discussing and learning it. Okay, they will go and study and come back with their questions.
Yes.
Okay, every day if
Yes.
you, there will be more doubts, more.
Weekly twice or
Because
thrice, try to keep.
weekly thrice it is possible because weekly thrice it is possible because the PCI is not a not a small protocol. It is a vast, and if we want to implement also, we have so many doubts. Already, I have seen my recent project also. PCI only, but in that PCI also we have so many doubts. What are the test cases? How we can develop in different scenarios like input output ports, different ports like IO configuration, all this. What is the test cases you have run? This scenario will be done. Every client interviewer they're asking this kind of questions. So that's why we can take it is possible to take weekly thrice, and we can learn every day some topics where whatever we have doubt we can clarify and we can discuss it in it.
Like next week we will be talking about configuration and architecture. So just go to the Mindshare book and find your questions, what you find complicated, and here we can discuss the tough things.
So I'm suggesting
Yeah,
like
okay.
weekly we can talk over a 2 hour or 2 to 3, and after full week we can understand and learn more things, and we can clear the doubt in next session. So maybe
Yeah.
like a weekly is better compared to the daily. So daily we cannot get the time to solve and read everything. So
Some
suggesting weekly, so we
yeah,
can
yes, yes.
vote for
Some people
everybody.
yes, some people are those who are work. Some people are working in office, like they want to go to office. So they sometimes some people have time, and some people they don't have time. So weekly thrice means it is for everyone. It is possible. There sometimes they will adjust the time also. We can move the further process like that.
Yes. So let us discuss PCI differential signals. So PCIe uses differential signaling, meaning each lane send both a positive and negative version of the same signal. So this technique doubles the pin count but offers two key advantages. It improves noise immunity since both signals travel closely together. Any noise affecting one affects other equally. So the receiver which measures the difference between the two signals cancels out the noise, improving the signal integrity. And next is the reduced signal voltage. So differential signaling operates with the lower voltages, reducing power consumption and allowing faster transmission speeds. So in PCIe, a common clock is not needed because PCIe operates using a source synchronous model. So in this model, the transmitter supplies the clock to the receiver indirectly by embedding the clock signal into the data stream. So this eliminates the need for an external or forwarded clock. Okay. Any question on differential signals? No?
So why we use this signal?
Anushka, just want to correct the one sentence. Like PCI can work on both synchronous as well as asynchronous clocking. Okay, but
Okay.
you have to take care of the PPM like on both sides, like when you transmit or receive. Okay, so it's not only a synchronous path; it is having a asynchronous clocking also.
Yes.
PPM means?
Parts per million. Like I mean, that is some kind of clock adjustment kind of things. Like uh, okay, we'll discuss this later in clocking section. We will
Okay.
talk about this.
Okay,
Okay.
so answer this.
Okay, let me try to answer this question. So, as he said, like we are sending data serially, right? Let's suppose I'm a transmitter, you are a receiver, right? So I'm sending
Mm-hmm.
data serially, like one data 0101. I'm sending to you. So it
Yeah.
is having data information, right? So you how you comes to know like at what clock I'm sampling the data? You can't, right?
Yeah.
So there, receiver side, you comes to know there is something called CDC, clock data recovery circuit.
Yeah. Clock domain crossing, CDC,
No,
right?
no, 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 no. CDC is different, right? That is a clock
Okay.
domain crossing. This is different. I'm going to clock
Okay.
data recovery, CDR, clock
Okay.
data
Clock
recovery.
data recovery. Mm-hmm.
So
Yeah.
basically, they are having some flip flop and mux will be there. And receiver side, as is told you, right? So you the first picture, right, where the north and south bridge was there.
Yeah.
Slot clock you can see there, right? The
Yes.
same
Yes.
clock you're giving to both, like your north bridge as south bridge, right?
Yeah.
So
33
this
megahertz.
clock
Mm-hmm.
can be is used to just recover the data because both you and me sample is same. We both are synchronous, right? I mean, we both working at same clock frequency, right?
Same clock
So
cycle. Yeah.
I can if I put the same to the flip flop and try to recover data, I can recover it, right? I mean something called
Yeah.
so that clock will feed there, and from there we try to recover the data. Okay,
Okay.
so benefit of having this, like we have reduced two more, I mean data, I mean lane, you can say, or physical lane clock. So clock also we are sending with data that will call as the clock embedded things. Might be see will explain in couple of days, like PMA section will be there. There see might be having something called uh, uh, PISO, parallel in serial out. Okay,
Okay.
yeah.
Yeah.
So there you will see like how it is getting embedded data and
Okay.
clock.
Okay. Yeah. Got it. Yeah. Okay. Sure. Thank you.
Yeah.
So we already did the bandwidth calculations. Was it useful for you all? Did you understand it properly?
Yeah, we understand, Anushka.
Yes.
Okay.
So one
So
question I have, like a Gen 5 supporting 32 giga transfer per second. So that is a speed, and it's like allow for 256 gigabyte per second, that bandwidth, right? So on that bandwidth we can transfer the data. Am I audible? Hello.
Yeah, that's just a speed.
Okay. On that speed we can transfer the data, right?
Right.
Okay. 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 Yeah. Sure.
So let us talk about differential signals and then we will end the meeting for today. And in next session, we will talk about the configuration and architecture. Okay, is that okay for everyone?
Yeah, it's okay. Can you know when the next session will be?
Do you want it every day? Is it comfortable for everyone or weekly? So let us discuss PCI differential signals. So PCIe uses differential signaling, meaning each lane sends both a positive and negative version of the same signal. So this technique doubles the pin count but offers two key advantages. It improves noise immunity since both signals travel closely together. Any noise affecting one affects other equally. So the receiver which measures the difference between the two signals cancels out the noise, improving the signal integrity. And next is the reduced signal voltage. So, differential signaling operates with the lower voltages, reducing power consumption and allowing faster transmission speeds. So, in PCIe, a common clock is not needed because PCIe operates using a source synchronous model. So, in this model, the transmitter supplies the clock to the receiver indirectly by embedding the clock signal into the data stream. So this eliminates the need for an external or forwarded clock. Okay. Any question on differential signals? No?
So why we use this signal?
Anushka, just want to correct the one sentence. Like PCI can work on both synchronous as well as asynchronous clocking. Okay, but
Okay.
you have to take care of the PPM like on both sides, like when you transmit or receive. Okay, so it's not only a synchronous path; it is having a asynchronous clocking also.
Yes.
PPM means?
Parts per million. Like I mean, that is some kind of clock adjustment kind of things. Like